So I was in a webinar. I was asked a very interesting question in this webinar.
What's considered best practice with Libre, and when to use constraints, and when the interdesign relations would make more sense in terms of robustness of the assembly and it less likely for it to blow up on you and stuff like that.
And I talked for a little bit, and then I made a promise.
If you're ever stuck for video ideas, that might be a good one.
That's great. I will make a YouTube video about it then.
Awesome.
So
That'd be cool. That'd be so
keep an
cool.
eye.
Thank you.
You bet. Keep an eye on our channel. Like and subscribe.
I will always.
So this is that video that I'm going to make now. Let's talk about the differences and the best practices, at least in my opinion, of when to use design in context to define and locate things in your assembly, and when to use regular assembly constraints. So what is design in context? What is it for, and why is it beneficial? Let's take a look at this assembly. I'll open up my pump and see some of the constraints there. So when we want to relocate this pump, we'll see that we'll watch this length of pipe and this length of pipe, and we'll find that as I change this to, say, 13, this pipe lengthens to still meet up where the pump is. Again, I'll give this something more drastic like -60. And as we watch this length right here, it shortens as I move the pump. So these pipes are updating with the pump's location. They are each their own unique files. They're not part of the pump. And so we have, an assembly that will update itself according to how parts locate. And this is why we edit in context. We created these pipes in the context of the assembly, so as the context of the assembly changes, the pipes update automatically. And so the big question is, where do we draw the line between when do we want to edit in context versus when do we use traditional constraint and dimensioning techniques in our assemblies? Now let's take a look at making an assembly here, and we're going to use some traditional constraints and make a little comparison. I'll put this cube down on the floor, and I can use an offset relation here. Again, very traditional, 2 inches perhaps, and then I'll choose this face and this face and go with an offset of 3. Just like that, we have a fully constrained cube, and of course the natural way is to take a look at our part. We'll take a look at its constraints. We can easily see just by the highlighted faces what the constraints are that we have between all these things. And I can make an adjustment if I wish. Now, let's make a part in context, right? And this is pretty easy. I just click on this part button here, and I'm taken into the part environment into an assembly. If I show my planes, I can see that these are the planes for the part, not the planes for the assembly. And so I can start making a part, but I also can reference the items from my assembly. I can highlight my floor and say that my floor is the sketch plane instead of any plane that is in my part. And I can make a rectangle. I'll say that I want to be 0.2 away from this wall, right? So I'm using the elements, the other parts of my assembly, to start defining this. We'll say with 1.25. And then where am I not constrained? Of course, I'll say maybe equal here. And I'll give this something like 4, and we are good. I'll choose extrude. And just like that, I've been able to make a part in the context of my assembly. Notice I can't click or drag it. Now, if I want to adjust this part, I can see that there are no constraints, right? No assembly constraints, despite it not being able to move, and that's because all the definitions of this part are wrapped up here in the assembly. If I go to edit this in a separate window, like what I've just done, I can see that I do have my dimensions, and I can adjust them, but I obviously just have some dashed lines in place of the parts of my assembly, so it can be kind of confusing to edit a part by itself when it was made in the context of an assembly. Now let's edit this here. So if I want to make some changes, right, I want to change the location or something like that, I can give this, say, a distance of 4 or 6, and my sketch updates, and of course the location of the part updates when it's in context. We'll also notice something else. I have my origin and planes right here, right? And when I go to adjust something, maybe we'll make this 20, right? The origin stays in the same place and my part moves relative to the origin. So if you have a complicated part, you're trying to make mirrors, things like that, it gets a whole lot more complicated defining a part in the context of the assembly. Now, there are ways around that. Let's go back to our main assembly. I'll create another part. And there I've created a part. I'm actually going to go back to my assembly again. And then I can say, okay, my new part, I'll show the reference geometry. And I can say, you know what? I want to position my plane in an offset manner. Let's make this 3 inches over. And now my part is positioned different, right? We're going to do another maybe 6 inches over. And you can see how my origin of my part moves. So I can use certain constraints and relations to try to position the origin of my part while maintaining some definitions in the context of the assembly. But again, it's a little bit tricky. So the rule for me is you can avoid all of this trickiness by inserting a part and then, whenever possible, using the regular assembly constraints and not edit in context features. So just kind of like when you're making a sketch and the fewer dimensions you use, the better. So it is with this. Editing in context has some amazing results, and those results are best realized when we use them as little as possible because the standard constraints are more reliable, more predictable, and then we build a better foundation using constraints to highlight the benefits of what those edit in context features are. So that's why we kind of see that we have parts that are shifting relative to their primary planes, or we have to constrain our primary planes first when we make a part in context, and so on. Those are reasons why we would want to use these sort of constraints instead of edit in context. So let's run back to this assembly. This is a Stratco contactor assembly. Very interesting assembly. And let's make a pipe coming out of the reactor into the pump. And to do that, I'll actually use the new part button here. And you'll notice now that I have the planes for my part, and I'm going to choose a plane for my part, so I'm not referencing the assembly for my sketch plane. So this is a part inserted into the assembly, but I'm not using edges or things to measure off of, so it doesn't reference our assembly yet. I'm going to say 6.03 centimeters. And then we're going to give it a little bit of an extrusion, maybe 0.25, right? So this is still an independent part. We're not editing the part like with context references in this assembly or anything like that. And we'll go back to our main level, and I'm going to constrain this part now, right? And I can move it around. If I can get my mouse over it, I'll move it. There we go. And I'll say, you know what, I want this face to be on this face because that's where a pipe is continuing from. And we're going to go with, of course, coincident. There you can see they're coincident. I'm going to flip it around so that our face is going the right way and apply that. And then we'll line this part up with our coupling or different size here. And then we have it show references. And I can say, yeah, you know what, I've got an axis right there. And because this can freely twist around, I'm going to say that this axis should be parallel. So I choose this line, and instead of concentric, which is not good, we're going to go with angle and say that the angle between them should be 0. And now we rotate it to a place where it can no longer twist, right? We have a fully defined part. And now I need to make a sweep so that it meets up with the pump. And this is where we would want to edit in context. So we've been able to apply all of our constraints, traditional constraints, to have a fully defined part, and then only the specific features that we need will reference external geometry. And I think that this is generally the best way to do things. There's always exceptions, of course, with strange situations, but I think as a general rule, this is pretty good. So we're going to edit here, and I'm going to grab a point and stick it right here and apply. Right, so now I've got a point right in the middle of my face. I'm going to do the same thing where I want my pipe to end. We'll put a point right there in the middle. And so I've kind of mapped out a start point and an end point. Now let's open up a 3D sketch and create a 3D sweep path for our pipe. We'll choose our start point. And of course I need to grab a line. So I grab a line and we got a start point off of our point that we made. We'll come over here and then we'll end on the pump. Now I know that I want this line to be parallel with this pipe here, so I'm going to grab a parallel constraint and make sure that my line here is parallel. And then same thing, I'll grab a vertical thing that won't change in orientation and make sure that my pipe ends at vertical. And I know that I want my pipe to travel along, say, the same direction as this edge, and so I'll align my pipe path with that edge. And just like that, we have a fully defined, and it doesn't turn black in a 3D sketch, but we have a fully defined, can't move it sketch purely off of relations. And so if something in the assembly changes, this sketch adjusts to that change. So I'm going to add some fillets, right? I'm going to add a fillet between these areas. We'll make that, say, 2 inches. And same here, from here to here, 2 inches. And now we should have a smooth path that we can simply sweep our pipe. Now in the 2D sketch, I'll go ahead and import this face. Again, maintain dissociation. And now I can run a sweep along this path. And we've got this beautiful pipe. Now I can go back to my assembly here, and there are a few interesting things that happen. First, I can move my pump. So I can pull up my pump here and say, you know, I want to move this, reduce this to, say, 13 centimeters, and this pipe automatically adjusts as well as this one. Then I might want to relocate it down a little bit further, and we'll say that this is going to be up to 60, and again that pipe readjusts. I can always add a constraint and say, yep, I want this coupling right there, and update things as needed. But not only does this pipe be able to self-adjust, but when I go to edit this in a separate window, and if I'm editing this all by myself, it stays aligned as it adjusts with all the other geometry. Like my origin is in a very logical position here. And so when I go to edit this, it's a lot more intuitive because I used the more traditional approach with assembly constraints and all of that. So we have a lot of the advantages and very few of the disadvantages with working with this. So hopefully this makes sense as to a good approach on when to use assembly constraints, which is as much as possible, and then when to use edit in context, which is only when necessary, and that helps keep things simple, and hopefully you're able to see that with the previous examples as well. Thank you for watching. Please subscribe to the Alibre channel, and we'll see you in the next one.